So in this question, we're asked to solve the differential equation to get y equals some function. So looking at this, the approach that I would try and take would be to use separation of variables in the equation. So what that means is you want to get on one side of the equation everything that has y's in it. So dy, 20y, y plus 2. And on the other side you want to get everything that has x's in it. So dx, x plus 1. So let's go ahead and try and make that happen. So let's leave the y's on the left hand side. So let's bring this y and the y plus 2 across. Alright, and on the other side, let's leave the x's. So that means we need to multiply this up to the other side. I'll leave the 20 here as well. Alright, so I think that everything has been taken into account there. With respect to this 20, it's just a constant, so it doesn't really matter whether you leave it on the right or the left-hand side. You should get the same answer. So now that I've got my variables separated across the equal sign, what I can do next is integrate. So if I integrate both sides, that means that they're still going to be equal. And this one here, alright, what we can see is that we've got, if we expanded the brackets here, it would be y squared on the bottom line. So that's not really so easy to integrate, because all we really know about stuff on the bottom line is if we have the integral of 1 on y with respect to dy, we could solve that to be the natural log of y, obviously plus c. But since if we expand this out we have y squared, there's no real rule that we can apply. So we need to turn this equation into something that kind of looks like this so that we can use the natural log as the integral. So how we do that is we apply partial fractions. Alright, so we have 1 over y plus 2. And what we can do is write ourselves a new fraction, which is a on y plus b over y plus 2. So a and b here are just random constants, just numbers that we're going to try and solve for. And what we've done is we've separated the bottom line into two different parts. So now we've just got y on its own here, which follows this rule. And we've got the first degree polynomials. This is like y to the 1, which is good, because we can also utilize this rule to integrate when it's in this form. So what we need to do is go through and figure out a and b. So the first step for that is to try and get a common denominator across everything. So the left hand side can stay the same because it's basically got the common denominator that we need. So if we want to get y plus 2 on this fraction, we're going to need to multiply the top line and the bottom line by y plus 2. And of course, multiplying by the same number top and bottom line, they cancel. It's like multiplying by 1. So let's do the same thing for this one. So we want to get y on the bottom line. So if we multiply top and bottom by y, we're going to keep the equation equal and have that same common denominator. So now all of our fractions have that denominator, so they're going to cancel out with each other. And we're just left with 1 equals a y plus 2 and by. So now we can pick some convenient values of y, which then allows us to solve for the constants a and b. So what I mean by convenient is if I let y equal 0, we're going to get 0 times b. So this is going to drop out of the equation, and the only unknown should be a. So we can directly solve for it without having to go through simultaneous equations. So we're going to get 1 equals a, y is being set to 0, and then we've got b times 0. So that goes away. So we're going to get 1 is equal to 2a, or a is equal to a half. So now we can go through and do the same process in order to get b out. So we can pick another convenient value. If I pick y is equal to negative 2, this bracket is going to go away to 0. So 1 equals a negative 2 plus 2 and b times negative 2. So that goes away. So 1 equals negative 2a, or a equals negative 1 on 2. Sorry, this is b. There we go. Alright, so now that we've solved for these constants, what it means is we can go back and substitute them into our equation. So up here, we now know A is equal to 1/2, so we can put that on the top line. And B we worked out to be -1/2. So this equation here that we started with is equal to this form over here. And now that we have it in this form with just y's on the bottom line rather than a y squared, we should be able to actually integrate it. So let's now go and substitute this expression into our integration symbol. Alright, so now we should be able to actually integrate our expressions. So the integral of 1/2 divided by y, the half stays out the front, and we end up with natural log of y, which was the rule that I had at the beginning. Here, again, we've got 1/2, it's negative, that stays out the front. If we take the natural log here, it's going to go to y plus 2 inside there. Remember, if you want to ever check whether it's the right thing, if you take the derivative of this, it should go back to what you had, and that's always a good check to know that you're on the right track. So I'm going to leave that there. This one we need to integrate. So if I brought the 20 out the front, like so, we're going to get 20 times, integrating this, we add 1 to the power, divide by the new power, so x squared on 2, and then same thing here. When you add 1 to the power, divide by the new power, it goes to x. The only other thing that I'm missing is that these are indefinite integrals. So I'm going to have some constant that falls out of the integration. Now, it doesn't matter what side you put that constant on, because it's just a constant at this stage. Yeah, it doesn't matter what side, because when you actually solve for the value, it's going to come out the same regardless of where you kind of put it. Alright, so now we need to rearrange it to get y equals, and this is where we have quite a bit of algebra manipulation. So the first thing I'm going to do is get rid of these halves that we have in the equation. So if I multiply everything by 2, they're going to disappear. So I'm going to get the natural log of y minus the natural log of y plus 2 equals, if I multiply this by 2, it's going to be 40. And then, of course, I can multiply this by 2 to be 2c. If I call this c1, let's just call it c2, which is essentially 2c1. All right, we're not really too fussed by all the other random numbers that are going to be attached to that constant, because in the end, it's just going to be some number on the end. All right, the next thing I'm going to do is try and put these natural logs together. So there is a rule where if you have the log of a minus the log of b, it's equal to the log of a over b. So we can apply this rule. So that means we're going to get the log of y divided by y plus 2 is equal to 40 x squared on 2 plus x plus c. And then to get our y's out of the natural log, what we need to do is raise it using e to the power of that. So e to the log y over y plus 2 is equal to, we need to do it to both sides to make sure it's equal. We get that. So remember that if you have e to the power of the natural log of anything, all that's going to end up equaling is the anything, or the x, as I've written it. So this is y over y plus 2. And it's equal to, now a trick here that we can also apply is that something to the power of a multiplied by something to the power of b is equal to them added together in the same base. So we can apply that here to get rid of this kind of c2. So let's separate it out as a first step. Okay. And then what we can do is, rather than writing this as e to the power of c2, remembering c2 is just some random constant, how about we let a equal e to c2, okay, just another number. So this is what we're left with. And I'll just copy down this side. Alright, so again, we're still trying to get y equals. So the next thing I'm going to do is multiply the bottom line up to the top, so that we have everything on the top line. Alright, if I expand out this bracket, alright, still got the y there. So now what I should be able to do is put the y's together using factorization. So let's bring them to the left hand side. So if I factorize, I'm going to get y times 1, leaves me with y. And then when this comes over, it's negative. I'm going to do the factorization at the same time. So y comes out the front, and inside the bracket, we're left with everything else. And the right hand side, we have that second term still. Alright, so we're at the final step where we get y equals, it's going to be this mess. Divided by all of this. Cool. So that is going to be my final answer. And we just need to remember that a is a constant. And the only way that we're going to be able to solve for a is by being given some conditions, like an initial condition or a boundary condition. So that's all there is for this video, and I'll see you in another one.